Okay, so we are Yuqi Liu and Xingyu Yang, and in this video we're gonna show our work for ECE454 final project. And in this project we did a hardware Trojan implementation designing using VHDL language. So the video is gonna consist of two parts. The first part is we're gonna take a brief look at our project in document version, which will show the mechanism and procedure of our hardware Trojan. And after that, we're gonna give a short demonstration of our project in ISE, which is an integrated software environment. And this software will allow us to simulate our code and design and see whether it's working properly or not. So let's first take a look at our function of the system. So the hardware Trojan that we designed is basically a system that we can implement it into a digital electrical door locker. And the Trojan will be able to keep track of what the user type into the panel. And whenever the user type in the correct password, it's gonna transmit out to another person so that we can see the password. And that would be the purpose and the usage for our project. So let's go further and take a look at our demonstration in the IC. So these are all the code, and after hitting running, as we can see, there are five names columns on the left hand side of the panel, and let me explain a little bit. So the password, that basically means the input that the user gives to the system. So whenever the user typing any numbers, the system gonna convert them into a binary version of the number and input it to the system. And below that's the clock and reset, and the door here, this door line means the output of the system. So as we can see, there are two states of the door, which one of them is 1 and one of them is 0. So the 1 basically means the circuit is closed, and which also implies the door is closed. And whenever you open the door, the circuit is going to be opened again, and the door is going to be open, and the circuit is also going to be open. So the first step of our test is we reset our system, and we can see the reset. So at first place, we reset our system. And after resetting our system, the door is kept opening, as is shown as 0. And at this point here is the user typed in a correct password for closing the door. So the door is turning to 1. And the second try of the user, the user tried an incorrect password, so the system status keeps still. And at this point, the user typed in a correct password for opening the door, so the door status again turning to 0. So this is basically the normal the normal act of the door under normal circumstances. And let's see another version of the hardware Trojan implementation version. So as we can see on the left hand side, under the name category, there is one more line which says code. So this is actually the main part of the Trojan implementation. So this actually gives out the input signal of the user. Whenever the user have a correct input password, this is going to be activated and transmitted out the correct password to another person. So as we can see, whenever at this point the door is actually not opening, it's actually closed. So the code line wouldn't keep track of anything, so everything would be 0. And at this point is after the user typing the correct input password, and the door is open. So the code line turn into 11101010, and that is going to be the input password of the user just type into the system, and it's going to be transmitted out to another person. So that's is basically what our system does. And we also discussed about how we can detect the Trojan implementation so that we can protect our security system. So whenever you had a Trojan implemented to some circuit or to some designing, the system gonna consume a lot more power than normal. So if you keep an eye on the energy consumption, the power consumption of the system, whenever it goes high abnormally, that's probably there's probably a risk of a Trojan that has been implemented to the system. And also there's a more subtle technique so that we can detect our system, is that we take a look at our designing of the schematic. As we can see, this is a Trojan implemented version of the circuit, and this one is a normal type of circuit. So the red spot just shows the abnormal spot of the Trojan implementation. And that will be it. This is our final project for 454, and thank you for your attention.